This is a quiz-like question for a unimolecular substitution and elimination reaction from chapter 7. So this is a good type of question because it's very comprehensive. You have to think about regiochemistry, stereochemistry, and all those other details. So we have some answer choices. And what I figured we should first do is think about the reaction itself. So a lot of times when people have a question like this, they kind of look at the answer choices first. And then kind of get their answer from there. And sometimes you can do that, but sometimes it's also a good idea to just kind of think about the reaction itself and then look at the answer choices. So I'm going to use that strategy. And we're going to kind of look at the next slide, and I'm going to draw out the reaction and think about all the possible products. And then we can kind of come over to this slide and think about whether or not they match up with our thoughts. So if we think about our reaction from the last slide, we had this molecule, and we know it's a unimolecular process. Our reagent is CH3OH. So the CH3OH is a weak nucleophile / base. And over here we have a tertiary plus resonance alkyl halide. So the first thing that's going to happen is we are going to lose that bromine atom. So loss of a leaving group. And we are going to make a carbocation. So it looks like this. So again, this is a tertiary plus resonance carbocation, very stable. But the key thing to note here is that we can have resonance. And the resonance is important because it could lead to multiple carbocations and therefore multiple products. Okay, so let's go ahead and draw out our other resonance contributor, where we have the allylic positive charge pattern occurring. This gives us a secondary plus resonance molecule. So products can come from both of these carbocations in the reaction. So that's what makes this question a little bit difficult, because some people might not necessarily think about the resonance contributor and the fact that it can make multiple products. So let's first think about what products might come from this first carbocation. We know that we can have both substitution and elimination take place. So the substitution product that we can make will look like this. We are adding an OCH3 to that positive charge. Notice that it does not have a hydrogen attached to the oxygen. That was removed in a proton transfer step. Okay, the second product that we can make is the elimination step. So there are 2 beta carbons on this original carbocation, and each of them has 3 hydrogens. So it doesn't really matter which of these beta hydrogens we take, we'll make the exact same alkene. We can make this diene as one of our possible products. So we have 2 products from the first carbocation. Let's take a look at the second carbocation. We can make 2 different substitution products from this carbocation, because remember that carbocations are flat. And so we can make 2 stereoisomers. We can have this stereoisomer, and we can have its enantiomer. So those are the 2 SN1 products. And then we also have beta hydrogens over here that can be plucked off in an E1 elimination. And that will give us this diene. So 3 possible products from the second carbocation. I'm going to go in and add the mechanism that we used in these examples. And then we're going to count up all of our possible products. We have 1, 2, 3, 4, and 5. So 5 possible products, because 2 carbocations, each of which can give us both SN1 and E1 products. So this reaction, like many unimolecular reactions, is what I call messy, in that you have lots of different products, lots of regio products and stereo products. So when we go back to our next slide, kind of keep these 5 molecules in your head, and we can use them to analyze which of the answer choices on the previous slide is not legitimate. Oops, let's see if I can go backwards. All right, so here's our original question. And it says, which of the following is not a possible product? So if you remember from our previous slide, A was definitely a possible product. A came from this intermediate. And C and D are both possible products because they came from this intermediate. So the only one that doesn't make sense is B. And why B? Because this is an OH group, and we won't make alcohols in this reaction. And the key reason why is because of our reagent. So our reagent here is an alcohol. And whenever you have an alcohol as your reagent in an E1 and an SN1 reaction, you're going to make ethers as your product. So an ether is like an ROR, like we have in this case. So alcohols won't be products. And that's a really common mistake that people make, is they don't recognize that this CH3 will still be part of the molecule and will still be present in the products. So just an example of a quiz-like question involving both SN1 and E1 chemistry. This example, I wouldn't ever ask like, which is the major product, because it is probably a little bit more complicated than we've discussed in class. You might need to consider the temperature of the reaction, for example, and it would be really hard to kind of know which one's going to be the major product. So this example is specifically good for like which of the following is not a possible product, and that's really how I would ask this question. To predict the major product, it would need to be a little bit more straightforward, but I picked this question specifically because it was not straightforward, and I wanted to give you kind of a messy example. So I hope that was helpful.